A very good afternoon to one and all present here, and thank you for joining us at 3 days international conference on computational techniques and intelligent machines in collaboration with the IEEE Computer Society, Waterloo Section Canada, MSEST Morocco, SIRG Egypt. It gives me an immense pleasure to welcome all the participants today for the 3 days international conference ICC-TIM 2020. I welcome all the eminent professors, speakers, and guests from all over the country to share their knowledge and vast experience with our community. The theme of this session is advancement in computational modeling and its application in education, health, and social care management. This session is chaired by Professor Dr. Sandeep Kumar, co-chaired by Professor Ithiram Raja Khan. And in this session, we have Professor Geet Singh Ojla as a keynote speaker. In this session, more than 8 papers will be presented by different researcher and faculty from the different parts of the country. So first, before inviting for the keynote speech, I would like to introduce Professor Dr. Geet Singh Ojla. Dr. Geet Singh Ojla is currently working as an assistant professor in the Department of Computer Science, Durham University. He worked as a postdoctoral research associate at Newcastle University, a research associate at Thapar University, India, a visiting researcher at University of Klagenfurt, Austria, and on various academic positions for more than a decade. He received his PhD degree from Thapar University, India. He has been awarded the 2018 IEEE TCSC Outstanding PhD Dissertation Award of Excellence. His area of research is energy efficient, reconfigurable, and intelligent surfaces. He has published numerous research papers in reputed peer-reviewed international journals. He worked on various research projects awarded by EPSRC, the Department of Science and Technology, India, and Austrian Federal Ministry of Education, Science and Research. Now, I would like to invite Professor Dr. Geet Singh Ojla for plenary talk.
Thank you very much for the invitation and so nice introduction. This introduction will save some of my time during my presentation, right? So thank you all for coming to listen to my talk, and I'll try to keep my talk as simple as I can because, when I used to attend different sessions in conference. A lot of technical things go above the head, and we don't get anything out of it, right? So I'll just share my screen. I'll not take time, right? So my talk focuses on edge cloud interplay using software-defined networks, right? So as I have been already introduced, I'm working as an assistant professor in computer science, computing, Durham University, England. Just alongside my talk, I'll just give you an overview to make it more interesting about what we are and what we are doing and at Durham also, and some beautiful buildings, beautiful locations coming across my university. So this is where we work. This is our university, right? The town hall building. Again, another look of beautiful Durham Castle. And so Durham is actually third oldest university in England after Oxford and Cambridge. It was founded in 1832, and it's a collegiate public research university. Only 3 universities in UK are based on this collegiate system. So it's consistently in top 100 QS world ranking. It's 86th ranked. And in different subjects, it's almost a record that it's 19 subjects on top 100 and 3 are in top 10 of the world. In THE also, they are consistently in top 100. And nationally, we are like, currently we're ranked 4 in UK, right? Not taking much time about myself, already have been introduced, so I'll try to skip this. I've been experienced in diverse levels. Like I have education from India, I have research experience in Austria and UK, and I'm working in industry also as a visiting researcher in one of the latest data analytics company. I've come across different levels of awards and fellowships, and published in a wide range of journals, ranging from top IEEE transactions, attended different conferences of Communication Society and Computer Society, and contributing on different editorials. And one of my latest book is upcoming in next month, right? So moving directly to the topic. So this is another look of our university. This is a modern look. That was older look, older England, and now this is modern look of our university. So my talk, if I want to brief about it, it will include three basic technologies, right? Ranging from cloud computing to edge computing and software-defined networks. So although they can be seen as three different verticals in research, but how to utilize them alongside each other to resolve the global problems or challenges of computing and communication, right? So this idea or the work we have done, in different verticals, we have performed this edge cloud interplay using SDN, and came out with number of publications and number of research projects. Some people call it osmotic computing, but I keep it very clear about it, calling it as edge cloud interplay. So starting with cloud, everybody must be knowing cloud, but I just want to share my experience. Like back 10 years back, in my college in India, right? So uh, when somebody talked about cloud computing, it was like something I was not able to understand what this cloud is, how cloud can be related to computing. You know? So it was some vague thinking or something, but this cloud has grown to such an extent that in current situation, when the entire world is locked in their boxes, right? And this is the only savior for the world. We are connecting to each other. We are using different cloud-based platforms, and the internet becomes the backbone to access any kind of service applications, and the community is still surviving, working at homes, right? So for example, these conferences are working online, right? Rather they don't give the experience we have in actual conferences. So that shows the growth of cloud, right? So cloud is nothing but it is an on-demand state of art service and computing infrastructure, and it's so powerful, and it handles different kind of services ranging of healthcare, transportation systems, and many more, right? It was incepted in 2000, and it has grown widely and significantly in terms of usage, size, computational ability, and underlying technologies. And it is very evident from because it has been adopted by different top ICT vendors like Amazon, Google, Facebook, Microsoft. So the cloud witnessed, like if we talk about stats, like it shows that it has almost doubled its market by 2020. It was projected. I'll not say much on this stat right now because it will be continued in some another slide. Because it was projected in 2016 that it will grow to double is so. But what happened in this year has changed the entire scenario for cloud. So this popularity or increase or projections were attributed to its pay as per use model. You can just use or access the cloud services or resources or infrastructure and just pay for whatever you have used it, right? So it's demand surge. You can use storage, computation, or networking resources as and when you require. So as a standard, NIST listed 5 essential attributes to cloud. First is on-demand self-service. Whenever you require, you can access the service, you can access the resources, infrastructure, and it has broad network access. And where these cloud services are hosted, these data centers, they are hosted at data centers that are located at different locations across the world. Maybe when I am accessing the service sitting in Newcastle in UK, my service is being hosted from a data center in Boston or somewhere else, right? Maybe in Bangalore or such sort of place. So it supports resource pooling, right? Different resources are pooled and they can be used, and they can be consolidated as and when required. You don't need to have service from a specific resource. As the demand requires, it will be shifted to another infrastructure as and when required. So it supports rapid elasticity. So I'll take an example, like if as an organization, uh, just take an example of energy, your energy billing in any country. Like for example, in India, we talk about that in summers we have huge demand of energy, right? Air conditioning, fans, coolers, and a lot of things. And as contrast, in winters the demand goes down, right? If we set up our own servers or such sort of infrastructure in our organization, and we are not utilizing it throughout the year as per our requirements, because requirements go up and down throughout the journey. So that is where the cloud helps us, because whenever we have more requirement of resources, it provides us, and whenever our requirement goes down, it just take away the resources and provide to anybody else, and we are charged according to the usage, as because it is a metered service like an energy meter or smart meter. Whatever we use, we are charged. So these all attributes make it a service-oriented architecture that supports in enterprise model. We call it as everything as a service. Although it has been like you can replace everything by anything like a platform, service, or infrastructure, whatever you want. So it provides you everything as a service nowadays, right? But otherwise, there are different platforms, different architectures that say you can use platform as a service, infrastructure as a service, or container as a service, and many more. So now coming to the challenges, due to these challenges, this research of edge cloud interplay came into existence. Although it provides enhanced flexibility and reliability attributes, but there are still challenges that are posed by the emergence of Internet of Things, that the need of real-time data storage, access, and processing. So the workload at cloud has escalated, and in some ways it is not able to provide, or it may not be able to provide the required latency or near to real-time communication that are required, or processing that is required by the Internet of Things devices. It has been more escalated due to smartphones, PDAs, body sensors, smart meters, and the order of data generated by these connected devices comes out to be zettabytes in the near future. So let's again talk into statistics. So Gartner report says 50 billion devices will be connected to internet by 2020, but it is again a different scenario in the current pandemic situation. So relaying such huge amount of data to cloud infrastructure creates a huge bottlenecks for the network infrastructure, right? So it leads to latency issues, and that those latency issues can further pose challenges for the quality of service for various applications in this environments. So what happened is that the world that was data poor world has transited into a data rich world. And underlying it, there is a requirement of unparalleled intelligence, because the services or application we are using, we're accessing, they are not ordinary services. So this generation of data, huge generation of data, can be attributed to number of aspects like abundance of mobile devices and wearables, instrumentation in every industrial vertical. And we have been listening about Industry 4.0 and all. So it's instrumentation and digitization of every vertical of industry, and the mass adoption of social networks. And it's like ambient living, digitization of our living, smart homes, smart offices, and all those things. So the bulk of data that is generated by IoT and these devices comes under two categories. One is machine-based and second people-based, right? And this huge increase in data collection, alongside there has been a lot of advancement also, right? And these advancements have created different scenarios or different opportunities in the form of use case scenario like smart cities, smart healthcare, and Industry 4.0, which we are experiencing in current times. So just let us see a journey, right? Everybody must be have experience, like we all listen to music, right? So talking about a long time back, when there were gramophones or radios or like you can see the growth, both sides, the challenges and the technological growth, right? We used to have a single gramophone disc player where you can store limited a song or a movie or something like that. So storage was limited, right? And infrastructure was huge, right? And then came Walkmans, cassette players, and then so on CD players, and then iPods, and in between there come a time when we can use services like Napster to stream your audio music using your computer or laptop. And now if we talk about current situation, we can stream anything, we can access to any sort of music or video using Amazon or Netflix or YouTube or any sort of Ghana.com, and just have readily available audio or video on your device. So all thanks to the growth of technology, and cloud computing is one of the contributor to this, right? But the demand, the surge of demand is posing a huge challenge for this cloud. Take another example, smart city. When we talk about smart city, specifically when we listen of smart city in India, right? It seems very simple, but at the background, it's very complicated. Just a snapshot of some of the services that are provided or some of the components of smart city, comprising of smart manufacturing under Industry 4.0, smart government, open data, smart citizens, smart health, smart farming, smart grid, smart building, transportation. And one can not even think of how huge amount of data is generated, and how the underlying technologies are continuously trying to cope to the demand of users or such sort of services. It's very complicated. This is just a scenario of a 1 million population typical smart city. In a 1 million population smart city, it generates about 600 zettabytes of data in 2020, right? It was projected, but the things have changed again. And 20 million of GB of data per day is generated, and 10% of it is transmitted per day. And it is attributed to all these different verticals of smart city, right? So these escalation of service, application, and data posed huge challenges in front of the cloud. And COVID-19, online is a new normal. We call it an online is a new normal. Everybody is connected to online services. If I talk about UK, 85,000 online businesses were launched during the lockdown in UK, right? And delivering to the needs of millions and millions. Like there have been huge download jumps, at least 60% in Italy, 30% in Spain, and 9% in the United States, if we talk about Netflix and Amazon Prime, right? So there has been huge demand or surge of accessing these online services, all dependent on cloud, right? So if I can say, this COVID-19 has been termed as a cloudy pandemic, right? It fuels huge spendings on like spending boom, right? So, but can this, the question again lies, can this cloud meet the demand of the customer? Yes, it can, although, but there are different compromises that we have to do, right? When we have to expand the infrastructure, we have to expand the resources, we have to invest capital. The data center, the size of a data center located in the United States, a Google data center or Amazon data center, is more than a small city in India, right? So it houses millions of servers that are continuously 24/7 running, trying to just provide the services to its user base. So to meet the additional demand, they have to expand it further, right? And then for example, I just take a single example of energy consumption. Energy consumption of a data center is so huge. Like for the data centers hosted in the United States, the energy consumption is equivalent to 2-year energy consumption of New York City. And New York City is one of the busiest and biggest city in the world. Right, so that can even survive. Entire state of Punjab can survive using that energy for 2 years, right? So that is the compromise that data centers have to do. I just took an example just of energy, and there are different parameters: capital investments, maintenance, and all. OPEX and CAPEX costs are booming, right? So what happened is that new technology coined by Cisco came into existence, that initially was thought to be as a parallel technology. But what I feel, or nowadays also different researcher feels, it's not a competition to cloud, it's a complement to cloud. It's just a cloud closer to ground that comes to the aid of cloud to handle the services or requirements or data processing that requires low latency or lower delay or near to real-time processing. So edge computing is nothing but a cloud close to the ground or data center in the box, right? It also provides computational and processing facilities at the edge of network and leveraging the machine-to-machine and device-to-device interactions. So it supports, it's widely distributed as compared to the centralized architecture of cloud, and it supports real-time or near to real-time processing, right? So we don't have to relay the entire data to the core, that is the cloud, but we can process some of the data locally and some we can set to the cloud. So there are different other terms or related things like fog, cloudlet, mobile cloud, and so, but more or less the purpose of all those technologies same. So the focus of edge computing is to bring the computing closer to the source of data where it is generated in order to reduce the latency and bandwidth usage. So running fewer processes in the cloud and moving others to local places like computers, IoT devices, edge servers, and all. This minimizes the long distance communication between client and server. So drivers of edge computing are latency, because a round trip delay from the data going to cloud and coming back is avoided in here. And bandwidth, it optimizes bandwidth, privacy and security. We can just secure our sensitive data by processing it in local segments, and only non-sensitive, insensitive data goes out of our enterprises, right? Because in EU and other countries, we have a lot of strictness in terms of GDPR laws, data protection laws. So local connectivity is, if we can't connect to cloud due to some, we can just use the edge computing services. And then when we are connected online to cloud, we can just offload the cache to the cloud for long-term storage. So it handles local dependencies. It focuses on de-emphasizing. It's centralized to become decentralized. So it's centralized as well as decentralized. There are different opportunities that you can leverage when your resources are running closer to the user, and it helps data processing by handling and balancing the load across cloud and edge. So it obviously, when some new technology comes up, it needs industry backing. So edge is also, as I said, it has been coined by Cisco, and different industrial verticals or IT giants are backing it up. Azure has come up with IoT Edge platform, and Amazon also have a Lambda at the edge, and a number of other people or researchers are also developing different toolkits or platforms where researchers can work and experiment their applications. So this is a typical edge computing model. I'll not go into detail. This is based on IoT Edge simulator that was developed in Newcastle University by my previous team, where I was working in the past. So it comprises of different layers. On the bottom layer, there's IoT infrastructure where the data is generated, and then there is communication layer, then there is an edge infrastructure layer, and finally the applications that are running for the accessing of services. So just a comparison between edge and cloud. Distribution, a cloud is centralized, edge is distributed. For when we talk about cloud, we have multiple hops of communication. Edge can be a single hop communication and source directly connected to the edge device. Latency for cloud is high, edge is low. Delay jitter is high for cloud, and for edge it's very low. Location awareness for cloud is almost silent, and for edge it is dependent. Location awareness and mobility are two important things that edge can support, right? So that's why it's very popular in vehicular technology or intelligent transportation systems. So location of service, cloud, the service is accessed within the internet, and for edge computing, they're accessed at the edge. So another comparison, one of our popular work, right? See, if you see two boxes, and the top is edge computing and the bottom is edge, right? So if you see them as a difference, you will see the contrast or comparisons. But if you take this as entire single box, you can say there is opportunity, because when we talk about edge and cloud combined together, we combine both of these boxes, top one and bottom one, and they are almost the double the capabilities or features that you can utilize as per your requirements of your services, underlying services, right? So there is an opportunity. It's not a competition, but it's a combined effort or complementing each other to serve the user base or the services in a better way, to provide more better quality of service and experience. So now coming to our edge cloud interplay architecture, this architecture comprises of 7 layers. Like, it comprises of core computing devices, objective functions, network devices, edge computing devices, access technology, applications, and actors. So each and every layer have different role and objectives to take care. As I'll just go directly to this architecture. So at the top level, there are actors in terms of different services, maybe smart, those actual devices or users which are accessing the services. And the second layer is about applications. It's like e-healthcare, transportation, infotainment, or online services, or e-education or so. Then comes the access technologies, which comprises a wide array of like 5G, 3G, 4G, as per the requirements. You can just shift across them as and when required. And then comes the edge computing layer, and then network, local network, and then the objective functions that drive the communications, like in terms of latency, energy, cost, service level of agreements, availability and throughput, and finally the cloud, the core computing layer. So that's the same thing. So edge helps us to provide a dual functionality, this edge cloud interplay. It provides a single hop communication to the mobile users to provide them services without assistance of cloud. And then second level, it connects to cloud to leverage its high-end functionality and tools. So we get the benefit of local as well as a global cloud. So, but there is again a big challenge, like again the problem of bandwidth limitations, because when we talk about, I've not added it to IoT Edge Cloud Interplay, but this focuses on IoT Edge Cloud Interplay, because when you take IoT into concern, there again huge movement of data, huge kind of migrations, and between Edge Cloud, again there are huge movement communications going on. So it again creates a problem of bandwidth limitation or some sort of bandwidth issues. So because the heterogeneous physical entities are continuously wirelessly connected to edge and cloud. So the limitation of resources at edge again requires sometimes shifting of major load to cloud data centers. So this workload is classified into delay sensitive and resource oriented. So the workload that requires more computing power, more compute resources, that is shifted to cloud data centers. So these huge number of migrations again add to an additional burden on the underlying networks. So now we need such kind of network and some sort of deviation in the architecture, that we have a network architecture or technology that is more dynamic and flexible to handle all these requirements of edge cloud interplay. So there comes the role of software-defined networks. So this architecture, it's broadly classified into 3 layers: cloud computing layer, edge, and network layer. And this network layer acts as a middleware between edge and cloud. Sorry. So because the reason for getting this SDN layer in between is that inefficient network can again lead to excessive energy consumption, high latency. So all the purpose of benefit of edge and cloud will go away if this network again creates a problem. So we needed a flexible, scalable, programmable, vendor-independent, reconfigurable network architecture, and that comes in the form of software-defined networks. In this SDN, I'll not go into more detail into SDN, but the key benefit of SDN is that it divides the data plane and control plane into 2 different layers, right? Rather, as compared to the traditional network architecture where data and control plane are coupled together at one level, SDN decouples them, and you can control the entire network with a global view sitting on a single machine. You don't have to go into each and every forwarding device router or switch to reconfigure or manually configure them. So you can just have a control sitting on remote server, right? So it is based on OpenFlow protocol, and it is it has 3 layers, again 3 planes: data control and application plane, and it can be varied across wide range of technology like 3G, 5G, 4G, Bluetooth, and all. So you can utilize them as and when required, as per your required transmission rates and communication standard chosen. So why we choose SDN? It's like without automation, because this SDN is an automated or a programmable network. Without automation, we don't have speed and scale, and this complex internet protocol networking processes, we have to configure each and every physical device manually. So SDN helps us that we can just sit on your machine and configure every entire set of network devices on a single go. So again, it is a promising technology in distributed environments. It supports virtualizations, and we can just create virtual networks or virtual tenants of different IoT edge cloud networks, and it provides more scalability and has a fine-grained control to support large-scale applications in Industry 4.0. By decoupling the data forwarding logic, it's from the control logic, its decision making is more automatic, and we can even adopt to intelligence strategies, right? So it is basically has a lot of role to play in large scale high speed computing system like mission critical applications, which require continuous dynamic reconfiguration and repolicing of network control and flow control. So this is just a visualization of what is happening. On the one side, there are edge devices. On other side, there is a central core computing devices. And in the middle layer, there is the network control that is based on SDN. And what happens is that these 3 queues are waiting, active, and suspended. The workloads coming into each queue are put into one of these queues, and then it is processed according to its active status. And this flow path queues, it's not only about classifying the workload, it's also classifying the traffic flows also as per their priority and requirement. You cannot deal with entire traffic or workload in the same way. When we are on Zoom and having this talk, if we are handled in the same way as the textual data or email is handled, we will not be able to listen to each other or communicate to each other. So this is the diversified capability of this architecture, that you can treat elephant-like traffic in the way that they require, and mice-like traffic in different ways. So email is treated as a different application, and voice over protocol, internet protocol, or video conferencing is treated differently and given different priority to the as per the requirements. So this is our architecture, right? Initially a flow generator from the end users, we get the flow, and it is divided into batch or stream processing flows. And then it is classified here in flow classification, and third part is based on application. I said it's based on if it's a video and it's email. So it depends. If it also depends on the business intent. In our further works, we even make this controller intelligent using deep learning and machine learning models to provide it and very integrated co-learning environments where you can just learn from each other and just improve this classification process. And finally, it goes to an optimization strategy selection, where we focus on the objectives. As I said, it all depends on the requirements. It's whether we need lower latency, right? Or we need lower energy consumption, or we have to meet SLAs or whatever requirements. So every application has their own requirements. If we say high priority applications like video conferencing and all, they need lower delay and even lower bandwidth, right? So, but some other application, they need more resources, but more bandwidth, but delay they can have any type of so this optimization strategy selects what sort of optimization algorithm we're running. And then if we require, for example, an energy optimal route selection, it will automatically route it to use on the based policy of that supports energy optimal route selection. If we need a latency optimal route selection, it will route to the scheduling policy that provides it to a more delay oriented or latency oriented scheduling. So some of the results I have just in terms of SLA violations and energy utilizations. I've not put up much about this thing as we have limited time. So what we got from this architecture is that we were able to sustain the SLA violations to the minimal, and we have optimal energy utilization as compared to the existing state-of-the-art architectures. And comparing latency, it's like when we talk about edge and SDN, latency is always guaranteed in terms of low latency as per the application requirements. So some of the works that have been popular based on this architecture or the extensions of this architecture is published. I'll just not discuss much. Like they've been published in different articles based on different environments. Like this was the first work, edge cloud environments, big data processing. And next we talk about V2X, vehicle to everything environment using blockchain. And then is healthcare ecosystem. And then you just go into industrial Internet of Things. And then we have vehicular edge computing. This is latest work. It's intent-based network. It makes this SDN controller more intelligent and uses, and this control plane, it runs an intelligent controller that adapts to the underlying business intent of the application and then provides them the flow routing, right? And this is again in vehicular environment. It's totally based on edge data centers, and it supports sustainability and energy efficient edge computing, right? So apart from these, my works, we have different applications, right? Starting from, I'll take one to one before ending this talk. So this is smart healthcare. This is osmotic computing architecture. It's just same as a different name for edge cloud interplay. So 3-layered architecture. At the lower layer, there's things, and then edge and cloud. All the data generated from healthcare infrastructure like hospital alarm or body monitor, motion sensor, humidity sensor, ambulances, they're then divided according to their requirements among the edge and the cloud layer. Then there are opportunities for defense and governance, like for military, humanitarian, public services, and public save in disasters or such sort of areas where you cannot transmit your data or push your data to cloud or core computing. You can use your local computing, edge computing appliances and provide computational support. Like you can take example of some drone-based missions where you can just not push your sensitive or critical data or services to the cloud, and you can serve them locally. And then in disconnected environments where we cannot be connected to clouds, such environments where you support speech recognition and such sort of biometrics and all, where you can just go locally and do some processing in the local environment, and then whenever required, you can connect back to the, when you are online, you can just connect back to the cloud. Again, cloud to edge it's again a sort of a application using edge devices to pre-process, pre-fetch, and filter unnecessary data streams intended for mobile devices, like pushing all the data from cloud to mobile or mobile to cloud against create bottlenecks, right? So what happens, edge can just pre-process or pre-fetch the data, filter it, and remove unnecessary data streams, and then transmit to both. Next is edge to cloud. So it can go both ways. Like when you talk about edge to cloud, you can just store the data in local cache of the edge device and in a disconnected environment, and you can just process it locally, and what you need to transmit or push back to cloud for further storage or further processing, you can do at later stage when you're connected to the cloud. Again, field operations like farming, or you can just connect to your ambulance or vehicle device of doctor. There is example, a physician diagnosing dengue patient with cell phone, right? And he's connected to his car or say some web infrastructure using his vehicle, right? So such sort of infrastructures in agricultural sectors or rural sectors where you're not connected to cloud, you can just access services readily using your edge processors. And again, this is a resource challenge environment. As I said, in Agriculture Tempo's case study of one of the universities provided here, you can just create mobile hubs moving across the cloud and utilize the services of edge computing as and when required. When you're in this infrastructure where you're not connected to the internet, right? You can create a local internet hub and provide services to the local environments. So finally, this is the future research paradigm is IoT at cloud ecosystem has different research strands where you can work, we can have different opportunities because there are a lot of challenges. So some of the research strands we are working currently and they're very demanding, and in the past also people have worked. I have listed here is a selection of edge data centers, load balancing, seamless data streaming, context-aware application engineering, lightweight processing. And on the other side, there are some future strands like compliance-aware cloud application engineering and threat-aware data streaming, decentralized security, and trust modeling of this decentralized security and distributed data storage. So I'm done with my talk, right? And this is two of my books, ongoing books that are expecting some book chapters till 20th December. So you can just mail it to me if you're interested with the abstract, or there's the email ID where you can put up this requirements. And thanks a lot. Any question or any sort of communication you want with me, you can just drop me mail. My email ID is here. Right? Thank you very much.
Thank you, sir. Thank you very much for this wonderful talk. If there is any query, then all the participants, if there is any query, then you can ask from Dr. Ojla. Okay. Now we are moving ahead with the paper presentation part. So first, I would like to invite Shreya Sharda for her paper presentation, and the title of her paper is a survey on news-based recommendation system using collaborative filtering, content-based and hybrid filtering.
Good afternoon, everyone. Am I audible?
Yes, ma'am, you are audible.
Okay. I'm sharing my screen with you. Good afternoon, everyone. I am Shreya Sharda. Today I am presenting my paper on survey titled A Survey on News-Based Recommendation System Using Collaborative Content Filter-Based and Hybrid Filtering. These recommender systems are used in every field, like shopping, movies, and any field you can name. Recommender systems are used in that. Recommender systems are basically divided into three categories. First is collaborative filtering, second is content-based filtering, and third is hybrid filtering. Collaborative filtering is used based on the people's recommendations or opinions. For example, if two people are discussing their interest in music, then they can be asked to rate the music according to their choices. After getting the recommendations and ratings, we can recommend the same music to third person also. Then this is the example of collaborating filtering. User 1 and user 2 rated high for news article 1 and 2 respectively, but for user 3 only news article 3 will be recommended because profiles of user 1 and user 3 are similar. This is collaborative filtering. Next is content based filtering. It depends upon the user's previous choices that what should be recommended to that user. For example, if I watched a sports news on my system, then my next recommendation given by the content based recommendation system will be sports news, sports article only, or any other news similar to sports. Hybrid filtering systems are the systems made using collaborative filtering and content-based filters. Uh, because there are some problems in both the systems, so we have to overcome with them with hybrid filters. Some of the problems are cold start. This is the basic main problem of the system. Cold start, sparseness of the data available, and it improves the efficiency of the system also. We can apply hybrid system using different kinds. First, we can apply collaborative filter and content based filtering separately and make a recommendation. Another way is to inbuild the collaborative content based into collaborative filtering. Another is take one model and apply content based and collaborative filtering in that and recommend that also. These are some merits and demerits of recommender average algorithms. First is collaborative. It is use memory based scheme. To use this data, we can add or remove data easily in it. But there are some limitations. It suffers from cold start problem, and there will be more computational power will be required because of huge amount of data available present in it. Another advantage of collaborative filtering is predict performance. You can easily predict the news articles, or the system you want to recommend. But the items, data is very uh, data is available in huge amount. That will be the limitation of the collaborative filtering. But on the other hand, on content based filtering, recommendation is based on users, so it will be easy to recommend because user profile is already available. And transparency, because user provide uh, user provide explanation why he likes or dislikes the data or system. Limitation is complicated tasks create suffer from over specialization problem, and acquiring knowledge from user is very difficult sometimes. This is the related work. In this section we will I will explain the literature on recommender system. First, collaborative based filtering. These are used in most of the models, but they are not used separately. They are inherited with model and make with content based model, and then it is used. First, I have discussed the model paper of Liu et al. It was presented in 2010. It was based on Google News. It created the web history of the user, logged in through their IDs, and Bayesian based system has been designed. The content based RS that learn user profile, collaborative filtering, and generate news according to them. Next paper is Liu et al. 2011. They have presented two-stage scalable modified news RS model. First is they extract features like news content, entities, pattern, popularity of the article. Popularity is based on the number of clicks or number of likes it get or anything like that. Next is Koi et al. Have presented two full solutions to resolve the problem rating based on rating of online systems. Its first aim was to inherit rating. That means the ratings given by the user. To enhance the quality of model, CEF contain collaborative filtering and sequential pattern analysis schemes have been used. The results are observed that CEF collaborative filtering with SPA perform better than only CEF. In 2013, Montesegrecia et al. Have introduced content-aware recommender system for journalists to identify similar data from distinct sources. This is big because they have used locations and user profiles to extract the features. Then this model can deal with heterogeneous data, uh, so it enhances the performance of collaborative filtering. Content based filtering. Bogers et al. In 2017 have presented a content based recommender system model. The authors have compared two models named OKP and language modeling framework, and they have used TF-IDF method. TF is term frequency upon inverse data frequency. The second one is used to create rank lists based on user query likelihood. The performance of the proposed TF-IDF approach as compared with OKP and LM approach has been performed well with mean uninterpolated average precision. This is the performance measure tool, mean uninterpolated average precision. Al-Murdatha et al. In 2010 have presented a fuzzy-based recommender system for Bengali news. It was used, the newspapers have been used in Bangladesh and Bengal both. It has used C-means approach to cluster the articles. The aim of the clustering of different articles to find the frequency of the keywords. Based on the keywords, the articles are clustered to recommend the news as per user's interest. In 2014, Adnan et al. Have designed a RS model for news Bangladesh using fuzzy logic method. The sample of dataset is not available on the web, therefore data was collected manually. After data collection, pre-processing has been done. After getting the essential words from the data, they have made priority list. In first priority, they have counted all the nouns. In second, the conjunction and prepositions have been identified. In third, subheadings that have short summary of the data or article are retrieved. And fourth, the recurring phrases have been extracted. Then the similarity of the words have been found. The similarity value and the date is passed as input variable to fuzzy network. The output is provided with sorted articles as per users' recommendations. In 2015, Liu et al. Presented a content-based collaborative filtering approach that used both CB and CF schemes in combination. Content filtering approach has been used to found rich data in news articles. On the other side, CB collected acknowledgement only. The, um, the performance was of that research was measured through root mean square error, and it shows that it outperformed with minimum RMSE of 0.075. In 2017, Okura et al. Have presented an embedding based approach that performed in three steps. First, they distributed articles. Second, they have created user representation with the help of RNN. RNN stands for Recurrent Neural Network. Using RNN, they have saved the history of the users, and that has been used to provide input. And third is to match and prepare list of the article. At last, the measured performance results show that the model performed better while accessing information from Yahoo. Then hybrid recommendation system. Both CF and CB suffer separately from different problems. Hybrid recommendation are the best one to use by many important e-commerce websites because they use best from both the models. Amazon, Netflix, or any other shopping sites or recommendation systems use hybrid models only. But there is still some more space on further development systems that recommend the current generation to obtain more efficient algorithms in wider application. In 2012, Wen et al. Have presented a hybrid recommendation system for news portal that provide tools for users to check check news articles which are relevant to them. They are based on weight terms. Web pages have been classified. On the basis of user navigation, past experience, and their likes and dislikes, that is preference model, the RS was designed. Based on web content and interests of user, data has been or news has been recommended to the system. The result has been analyzed in terms of precision and recall. The zero point 0.7 has been determined. The average precision rate of zero point 0.7 has been determined by the hybrid model. In 2013, Jonalageda and Gouch has developed a RS model for news article posted on Twitter. The news article was based on rank of or popularity of the articles, which was based the popularity was determined by the number of tweets or retweets that got, and additionally a profile was created for the user depending upon their interest and the ratings they have given to the news. Performance was measured in terms of mean cumulative rating. Poor results have been obtained while considering individual feature like popularity or user profile. When both of consider in combination, the system performed better with the highest cumulative rate of this. In 2016, Vienna et al. Have presented a news RS model for mobile-based news application. That model integrated the content-based recommendation system with geo-referred RS technique, and prepared model has been supported by long-term and short-term user profiles while taking into consideration about their locations, and these were designed for Portuguese newspaper. Initial pre-processing has been applied to extract subtitle contents, tags, information regarding title. After that, data was clustered using Lingo algorithm supported by Carrot framework. The similarity between the cluster data has been found out using cosine similarity measure. The performance has been analyzed based on rating average value. In 2020, Lee et al. Have presented a document to vector based hybrid CF, which uses keywords based on online shopping history of the purchased items by the different users. Efficiency was determined based on online shopping mall data in Korea. The results show that the increase in recommended product, the performance of the hybrid systems has been also increased. The performance of conventional CF approach has been decreased with the increasing recommended products. Performance measures. To measure the efficiency of any recommendation system, following parameters need to be measured. First is mean uninterpolated average precision. It uses binary relevance of news article. It averages the precision of score obtained by retrieving every significant document. For the documents that have not retrieved yet, have sign and precision score. Accuracy. It is directly related to receiver operative characteristic curve. More the area considered under the curve, higher the accuracy of the system. Mean reciprocal rank. It is a ranking matrix and used to evaluate the appearance of positive instances in the news article. Normalized discounted cumulative gain. It is used to determine the ranks of all positive instances. The closer the value near to 1 is considered to as better recommendation system. Precision. It is the fraction of data retrieved from the news article that is relevant as per the interest of the user. Recall. It is a fraction of relevant information extracted from news portal successfully. Both parameters can be evaluated by measuring the rating of participant. Let the RS model as a fraction of news of the user have rated the news by a fractions of news from the list of relevant content is the total rated news rated by the user as a relevant content. Conclusion. The RS is a technique that uses multiple schemes to design a RS model. These are content-based, collaborative, and hybrid. The approaches have been proposed by numerous researchers in the academic as well as academic by the industries to grow enterprises and increased productivity and the part of industrial strength of the past decades. These systems open up the new possibilities for retrieving personal information on the web. This paper has presented the introduction about three approaches, also their strengths limitation. Recommendation model has been discussed and measure to quality and performance of recommendation algorithm with various schemes used to develop efficient recommendation system. Thank you, and these are the references for any further query.
Yeah, Shreya, I have a question.
Yes.
How successful are the recommendation systems these days?
Sorry.
How successful are these systems which you are talking about, hybrid and all?
They
What
they
is the
are
success?
they are these systems are used everywhere in any field you name, and these are used, be it news recommendations, be
Hmm.
it article mean products of sales, Amazon, Netflix, movies,
Okay.
any field these systems are used, and they are highly recommended by everyone these days. Supposingly I want to check a movie, I was watching a movie, and
Yes.
instantly I got second recommendation of the movie similar to that. And the
Okay. So, what is the platform that you have been looking for the development of this system?
actually I am using Python for making a news recommendation system.
So, in Python, you're using Jupyter or you're using Colab and all?
No, actually I'm working on Spider.
Okay, okay.
I'm using Spider platform to make news recommender
So,
system.
which library has been used by you for this recommendation system?
Actually I am working on deep neural networks.
Okay.
Yeah,
So, learning. Hmm.
I
So,
have
which
been
library
using,
you're using? Keras?
yeah, Keras I have been using.
Okay. Chalo, keep on doing the good work. Best wishes.
Thank you so much.
Yeah. Thank you. Yeah, over to the host.
Anji, thank you, sir.
Yes, sir.
So we are going for next presentation, that is by Amanpreet Kaur Sidhu. Are you here, Amanpreet Kaur?
Yes, sir, I'm here.
Okay, are you going to present two papers here?
Yes, sir.
Okay. Okay, I am making you host,
Okay,
so
sir.
you can share your screen.
Thank you, sir.
I am requesting you, please conclude your paper presentation within 10 minutes.
Okay, sir. Okay.
Okay, thank you, Amanpreet.
So my screen is visible.
No, Amanpreet, your screen is not visible here.
Okay, sir. Is it okay now?
Yes, yes, now this is visible. You can start.
Okay. Thank you, sir. Good afternoon, everybody here.
Afternoon.
I'm presenting my topic on the moderating effect of gender and marital status on the relationship of occupational stress, well-being, and family behavior. Myself, Amanpreet Kaur, Research Scholar in Management Department in IKG PTU Kapurthala, as well as I'm working as an assistant professor in Punjabi University campus, Talwandi Sahib. My field of interest is basically I'm from management background, so I'm working my paper on the job stress, on the occupational stress. Basically the contents I'm going to cover in my study are model of the study on which I'm working. I have worked this paper, objectives of my paper, methodology that I have used, measures and methods, the result I found from this paper, and ultimately the conclusion and theoretical implications for the future studies. First of all, I have to introduce about the occupational stress. apart from the track of this conference. That's why I have to have a little bit introduction about the occupational stress. Basically, stress has become a the key concern of the present time. In India, 82% people experiencing stress due to finance, work, and health-related concerns. Over the most recent decade, occupational stress turned into an issue of immense issue. As per the National Statistics 2018, 5,95,000 workers of Britain were suffering from the stress. So stress is a power that pushes mental or emotional factors to make strain in an individual. This is the model of my study in which I am going to basically check the impact of job stress on the health as well as on the family behavior. Secondly, the role of the gender and marital status or their moderating impact on the relationship, like the role of the gender and marital status on the relationship of job stress and health condition, and also on the health condition and family behavior, and the impact of gender and marital status on the job stress and family behavior. So my present work will concentrate on to study the moderating impact of gender and marital status on the relationship of occupational health, on occupational stress, health condition, and family behavior. The methodology I have used in this paper is data is collected basically from the Punjab State Power Corporation Limited, located in Punjab. The respondents' designation varied from the junior engineer, assistant engineer, senior executive engineer, superintendent engineer, and chief engineer. The response rate of my study was 59%. I have finalized 621 questionnaires from the all distributed data. I have worked on a primary based data. So I have used the G-Power software to check, to minimize, to fix my sample size. Among the 621 respondent of PSPCL, 566 are male, 55 are female. 446 respondents were married, 11 were single divorced, 64 were single never married, 90 were single widowed. For organization, 298 employees belongs to generation sector and other was to the distribution sector. So I also selected the tenure, their experience towards the PSPCL. For this methods, for this data, to settle this data, I have used the Myers, that I have used a validated scale that I have already validated in my previous paper that was published in the science publications. In that scale, I have choose the 10 parameters that was selected to find out the impact of occupational stress on well-being, and 7 parameters used to analyze the impact of occupational stress on the family after modification in various previous research works. All the construct were measured by using multiple indicators on 5-point Likert scale. So then there are, these are the results. These are the variables I have used in my study questionnaire. Basically, this is the part of my questionnaire in which I have used PLSM methods. This is basically a software through which I got my results. These were loadings, composite reliability, and average variance extracted. This is correspondence according to their variables. These all are my basically part of my questionnaire, due to which I get these values. Now I'm going to explain these values of AVE and composite reliability. Indicators with poor factor loading, like A37, there is A37, A38, 39, A40, 41, F3, H4, and H7 were deleted for the next conclusion because of their low factor loading. Composite reliability proposes better estimation PLS based research. So composite reliability is preferred for this study. Reliability score is accepted from 0.6 to 70. So, though the results found in this study was comparatively good and adequate according to the previous standards, so the convergent validity test is most frequently used to check the validity. Then I use the discriminant validity by the foreign and Lacker criteria. This criteria helps me to get the best values, to get the appropriate values. Discriminant value is basically to examine the construct's validity. As shown in my table, as per foreign Lacker recommendation, all the correlation among the construct should be lower than AVE's square root value. All the calculated value of AB in this table, as shown in this table, are higher in square root than the correlated value among the other constructs. Next is the path coefficient testing for all the hypotheses that I have framed as it is shown in table. H1 is the relationship among the occupational stress and family behavior. H2 is the relationship between well-being and family behavior. H3 is the relationship between occupational stress and well-being. So according to this analysis, these path coefficient standard regression weight R square, F square, and Q square are in their significant levels. The relationship between occupational stress and family behavior, well-being and family behavior, and occupational stress and well-being are significant. All these relationships have appropriate path coefficient and T statistic values. T values are above 1.96 and P values less than 0.05 are considered as significant. So result displays a negative relationship between the occupational stress and family behavior. Thus H1, H2 and H3 are accepted for the study. Now the next hypothesis for the H4 is relationship between the well-being and family behavior. H5 is between the occupational stress and well-being, and H6 is occupational stress and family behavior. So in this relation, all the so in this relation, all the values are as pair is distributed among the pairs like merit. A pair-wise evaluation of two groups was formed for male and female separate data sheet. Like female were 55 in numbers and male were 566 in numbers. So by the method of bootstrapping, I have calculated the moderation analysis of female and male for three relationships. The female are found stronger and significant than male respondent in two parts in the relationship of well-being and family behavior and occupational stress and well-being. T value is also appropriate as per the table value, like T is greater than 2, whereas third path is insignificant. It is found from this table that males have a high moderating effect in the relationship of occupational stress, well-being, and family behavior in comparison to the female. I found that these results from this tables. I got a discussion about the results, like how much valid is this my model. As I showed all my hypothesis and relationship. On the basis of this, in discussion I come to analyze that how much valid is my model valid for further studies. After establishing the coefficient of determinant and predictive accuracy of all the path coefficient, Q square value is analyzed to check the predictive accuracy of proposed model. The blindfolding procedure measures this. The Q square value measures the relevant predictive power of extraneous variable against the endogenous variable. For direct impact of occupational stress on well-being and family behavior, the Q square is 0.040 and 0.301. Result indicates that the predictive relevance of the model for family behavior is high. and for well-being, predictive relevance is low. F-scale effect size of overall model is considered medium to large. Occupational stress has a very less impact on family behavior and medium impact on the family on the on the well-being. So to conclusion of my this paper is the path coefficient results reveal that there is significant relationship between occupational stress, well-being and family behavior. This could infer from the results that occupational stress negatively influenced well-being and family behavior. Similarly, well-being positively affect family behavior. The impact of occupational stress on family behavior was found more due to well-being rather than the direct impact, as occupational stress impacts on family behavior due to the health conditions only. If health conditions varies, it will suffers, then ultimately it will impact on the family behavior. Thus well-being has a mediation impact on occupational stress and family behavior. The female were found stronger and significant than male respondent in two relationships such as well-being and family behavior and occupational stress and well-being. Female have high moderation effect in the relationship of occupational stress, well-being and family behavior in comparison to male. While in marital status, unmarried respondents were found to be stronger and significant than the married respondents. Theoretical implications of my study is the present results confirmed the impact of occupational stress on the relationship of well-being and family behavior. There is a significant relationship between occupational stress, well-being and family behavior. Occupational stress negatively impacted well-being and family behavior. Thus, in general conclusion, this study will provide a wide impact of occupational stress on an individual persons. Secondly, it was found that well-being has a significant relationship between the with the family behavior. The impact of occupational stress on family behavior was found more due to the well-being rather than the direct effect. This study also contributed to the literature by examining the moderation effect of gender and marital uh, status among the relationship of occupational stress, well-being, and family behavior. To the greatest of our knowledge, no supporting literature is found in
Thank you, Amanpreet.
previous
Thank
studies.
you. Thank you. We don't have to read everything from the slides. We've been presenting the paper nicely, and you have and the last two slides have been repeated. So, how satisfied are you with your study in COVID times? For
So
other times, it's okay, but if we take COVID into account, how
yes, yes,
far?
sir.
Yeah.
Yes, sir. So due to COVID, everybody is feeling somehow stress in any way. Like or
Mhm.
either they are professional, either they are working, either they are student also. So I'm working here, I'm studying here about the occupational stress. So or either we are working like we are in teaching profession, we have some burden rather than physical classes. Same as in industry, same as in IT sector. So ultimately, or either they are working from their home, but they are facing some different type of problems, like continuously they are facing laptops, they are continuously working on online sources, so they are feeling some stress. It impacts on their health also, and this health will ultimately impact on their behavior towards their family. They
Amanpreet,
can.
will you make your own system, or will you, because you have been using the G Star software?
Yes sir, G star software sir.
So will you be making any of your for your future work? Will you
This,
be making any other software?
no, sir, I cannot introduce any my own software. Sir, I just used this to specify to confirm my results only.
Okay, okay. Thank you. You can start with the next paper.
Okay, sir. Thank you, sir. So good afternoon again, everybody. It's also a related work to my previous paper, but its results are far different from the previous paper. This is basically mediation impact of health condition among the relationship of job stress and family behavior. These will be the contents that will be covered in my next study, model of my study, objectives, methods and measures, and results and conclusion of the study. So job stress basically has become immense concern. 46% workforce in Indian firm, 46% are suffering from job stress. Over the last decade, job stress is become an emergency issue for every organization. They have to tackle it timely. Otherwise, it will make an adverse impact on the performance of the employees also. The impact of stress are multifarious. Stress can impact on body and behavior, but stress has a negative impact on the health of the employees. Higher stress leads to the poor health. Stress can negatively impact the psychological well-being of employees. Also, stress increased labor turnover, inadequate performance efficiency, and absenteeism in the companies. It was found that occupational stress was significantly correlated with the poor physical health and the family behavior. The job stress employee the job of employees working in thermal power plant is considered very stressful. In Indian in Indian context, the need of the electricity is demand is increasing at very high growth rate. High work pressure leads to stress. The job of employees working in thermal plants is considered very stressful. Several factors of their job contributed to reactions like workload, repetitive and monotonous operations. In Indian context, researchers are aware about the job stress and its implications, but not much work is done for the impact of the job stress. There is a need to study the impact of job stress on the relationship of health condition and the family behavior. Therefore, in present study, based on the previous studies, we made an effort to examine the impact of job stress on health condition and family behavior among the employees of Punjab State Power Corporation Limited. This is the model of my study, that how job stress impact on health conditions. What are the various factors that directly contribute to job stress, and their impact causes some impacts on health conditions. Ultimately, it will impact on family behavior. How health condition has a mediation role between the relationship of job stress and family behavior. So in my present work to study, I will study the impact of job stress on the relationship of health condition and family behavior. Methods and measures I have used in this, that I have collected my data from the PSPCL, Punjab State Power Corporation Limited. I have used my already validated scale uh, for this study to collect the data, and data is again same data I have used in this paper, that is collected from 621 sample sizes. Discriminant validity of this study is to check the validity, basically that how much discriminant validity is basically used to estimate which extent a particular construct is different from the other. That construct, that factors I have used in my study. So this discriminant validity basically implies the uniqueness of the construct. In this, I have used the HTMT, that is heterometrate ratio method, that is used to check to help the assess the high sensitivity and specificity rate. So HTMT, the threshold value should be lower than 0.90. As shown in the table, all the value of construct are below than 0.90. Next is path coefficient, that is to specify the my hypothesis to check the relationship among the other all constructs, as well as H4 indicates the role of the mediation of health condition between the relationship of job stress and the family behavior. For assessing the convergent validity, the redundancy analysis for formative constructed, I have used the values of beta, of mean square, t statistic, p value, and the decisions for this from this study. In this statistic structural model assessment, the relationship between job stress and family behavior has the path coefficient 0.46471 at the significant level that is accepted for the further study. T statistic for this is 2.720, that is above 1.96, so that is considered accepted. All the values in among all the relationship are above the threshold value, so all the hypotheses are accepted for this study. This is the bootstrapping method that shows the relationship, the impact or the R square values of the among other relationship. The t value is 3.790 for the relationship of job stress and health condition. It shows that the proposed path model between job stress and health condition is significant. Mediation analysis is basically for to show the relationship among the relationship of health condition between the job stress and family behavior. Among this, we got the results. R square is 0.093 for health condition and 0.586 for family behavior. It shows that the relationship uh, between both is improved by 58% by adding health condition as median among the relationship between job stress and family behavior. So, to check the validation of this model, that how much it is valid for the further study, I have used the model have predictive relevance against endogenous variable. In this, the value is 0.040 and 0.30. So result indicates that predictive relevance of this model for family behavior is high, and for health condition predictive relevance is low. So, based on the conclusion, I found that movement demand is found as the most influence factor to create job stress among the employees. Due to movement demand, at the moment, what is demanding from the employees, that their job duties, their responsibilities, their working hour, that creates more stress, as it can also be related to the present time, like every employees, either they are working from home, either they are present in their office, they have to devote their much according to the need of the time. So it is basically the main cause, the most influencing cause to create job stress among the employees. As the smart pls sem also analyze the relationship between job stress, health condition and family behavior, that is found significant. Also, health condition has a mediation impact. Direct impact of job stress on health on family behavior is 51% only. But by adding the health condition as a mediation among the two, it was impact improved by 58%. So it has a clear mediation role of health condition among the relationship of job stress and the family behavior. Practically it will help. The results are confirmed that the impact of job stress on the relationship of health condition and family behavior. So it will help for the organization to found the real causes of their job stress that impacts the health of the employees. Further, it will impact on their family relations, on their psychological factors, as well as their performance also. So in journal, this study will provide a more complete impact of job stress. It will help for the organization to find out the real causes of job stress among the employees, how they are impacted, and further it will also help as a future study that how it can be coped, how which coping strategies can be used to overcome these stress so that the employees can be fit on their working, as well as they will prove they will provide a best performance to the organization also. So geographical area for this, for my present study was limited to Punjab state only. It can be expanded to the other states as well as to the other organizations also. For the future study, it can also include the organizational factors. In my study, I have included only the personal factors that can cause stress. Individually, employee is feeling about the stress, but in future, what organizational factors imposes stress on any employee. Secondly, any domestic problems, their personal problems, their behavioral problems can be studies linked to the job stress also. Thank you. That's all about my paper.
Yeah, Manpreet, thank you for this. And this was very much similar to the previous one. Here also females are superior in this study.
Yes, sir. This
No.
females is not concerned in this study. This study was only about the mediation role of health condition only.
Yeah,
That
that's why
was
I asked. Thank you. Thank you. I got the answer. But wouldn't it be better if you apply it to some other data set other than the Punjab Electricity Board?
sir, actually it was my PhD study. I done my thesis with that, so that's
Okay.
why I was actually I got different issues from my thesis.
Okay. Now apply it on some other data source. So that might help you to develop it for some company and all.
Yes, yes, sure, sir, sure.
Okay. Thank you, Amanpreet.
Thank you, sir. Thank you so much.
And the next paper presentation, the paper from the Mehtab Alam, and the title of the paper is Business 4.0, a new sustainable revolution.
Hello, am I audible?
Yes,
Yes, you are
you are
audible.
audible. And I request to you to conclude this session within 10 minutes.
Okay, no problem.
Okay.
Keep your timer also better and
Yes,
conclude
we
as
have a
soon as
time
you
constraint,
possible.
so that's we are.
Okay, okay. First of all, I would like to introduce myself. I am Mohammad Adnan Beg, and this paper is done by Mohammad Mehtab Alam. And due to some internet connectivity issues, he's not been able to present his paper. So I am giving presentation on his behalf. And it is about Business 4.0, a new sustainable revolution. As we all know, the new technologies
Please
have.
share your screen, better.
Sir, I have shared my screen, I think.
नहीं अभी आई नहीं है बेटा. You'll have to share the screen. Take a minute.
Okay, okay, sir.
Yeah, it is visible, better.
Okay.
You can proceed.
So it is about new business models. As a new business established or founded, it exercises carefully crafted business models. Like all are the corporate world, and the new companies are they target what are the customer values, and what they can deliver from their side best, so that for the profit maximization, for the more satisfaction of the customer, and to understand what are the different needs of the customers. So most of the corporate world and the companies are adopting new technologies. For this reason, major examples that we will talk about later in this paper are Uber, Amazon, and Google itself is using business 4.0 model, and it has shown exponential growth in the over the years in business tactics of Google. So let us start with this paper.
Yes, better move.
The elements of the business model, there are some method. The first one is to choose the technology for the business model. First of all, whenever we are creating a business model, so there are a lot of technologies available to develop a model. So first step is to decide a proper business proper technology for the development, so that it needs to be efficient in many ways. And the second one is to benefits, look for the benefits of customer for using product. Obviously any customer will buy the product if he or she will understand what are the benefits of them in that product. So you can't sell them anything. The company, the business the management have to make understand that then the customers that this product is used for this work. So this is very important. I think the every uh, every management of a business model should target the customers benefits, so that they can better understand why they need to buy that product. The next one is to target the market segment. Now whenever you have decided what customers no, why customers will buy, next thing is to target the market where to sell that product. Obviously not everything can be sell at any market. So first of all, these all things are done through the through analytics by the management of any organization. So in this step, the organization will target the market segment, so that they need because they need highest profit in the business. So obviously they need to target a proper market. Next, to check the avail income streams from where
Move
they can.
forward. Better method, move forward. We have already read this. Yes.
A traditional, what is the problem between a traditional business model and what for business 4.0 is, how business 4.0 model is better than traditional business model. In traditional business model, there are manufacturer, distributor, retailers, and franchise. Manufacturers are the one they which are creating the product. So there are many ways to sell the product. They can directly sell the product to the end user, that is the business to consumers model. And they can also set a different business for the sales to sell that product to the customer. There are distributors who can take the product from the manufacturer and then forward them to the retailers or directly to the end users. But what is the need of a better model? First of all, this is there is a major problem in this, because we see in traditional business model there are manufacturer, distributors, retailers, so there is a lot of hierarchy. And due to this it creates a problem in deciding the correct price of the product till it reaches the end user. So it needs to be although it's a very popular model and a traditional model, but due to its unsustainability, it needs to be changed. So here's the business 4.0. It is basically this term is introduced by TCS, and many other companies are using this logic. It is only a framework for to decide how business will behave, business work will behave to make available digital technologies, and to gain advantage in creating customers value.
Better move forward.
Okay,
Yes,
sir.
better. Yeah.
So business behavior creating exponential values is like technologies like big data, IoT, and AI allows linking of cross-selling of the different products and services. We know in Internet of Things there are information which is linked to each other, known as the things. That's why it is the Internet of Things. So it creates a network it creates a network so that everything is interlinked with each other. So in this model, whenever we use new technologies, so every information is interlinked with each other. So the organization will get benefit for this. And for example, they will know about the market value easily, about the which we have talked about earlier, like target market for the for a particular product. So this will create a different this will create a different impact on the business. And leveraging ecosystems, digital technologies are variously expanding the boundaries of the industries and landscape of the competition. So business across the many industries are working together to deliver greater value and services to the customer. If we talk about embracing risk, digital technologies have enabled the business to gain new levels of agility and flexibility in embracing the risks. Adaptation of digital means large scale restructuring and transformations of the processes. There is embracing risk means if we analyze the data carefully by using major technologies, like if we talk about data mining, so there is a lot of data present. So there's
Move forward.
sorry sir, I was
Your time is running out. You can come into the
okay.
diagrams and all.
So there are technology pillars like agile. Agile is all about agile means to very quick. So agile means to develop working software which is of good quality in a better time to get better results for the customers and competitors in the market. And for automation, with the power of data analytics and AI technologies, applications can monitor the production and delivery of the products and services. They can also control it. It will be getting unmatched returns. So business 4.0 at work, if we see how it is changing the growth of the how it is helping the in the growth of the organization. So first we will look at Google's exponential value. We all know Google, when Google was started, was just a search engine, and by using in a very short span of time, it becomes integral hub for advertising and marketing. First of all, they started it for like a search engine, and then they start earning profit from the advertisements and all. So it all started providing free email services, and then scheduled commercial use as well. And today the Google products and services are grow, and it is $1 trillion company in no time. Second one is Amazon. So we all know Amazon is the largest e-commerce marketplace right now, and most valuable policy company. When what is the main thing is, they are the new organizations through the business 4.0 model, that they are working for data analytics, and they are really working on data. So like if we see something on Amazon, so it will automatically show the recommendations. So that is also a result of data mining and analysis of the data. Steps to achieve sustainable business models. First one is building business belief. So for the very first to start this, you have to believe that changes will be positive, and everything will change according to time. Like embracing the changes, if we talk about Nokia, so they didn't adapted the Android when Android came into the market. So we all know the result. What is the why they I mean what happens when they don't adapt the Android. Developing value propositions, and growth and comfort don't coexist. So if you have to grow, so you need to leave your comfort zone first and play in the open.
Move forward quickly. Time is running out.
Okay, sir.
Yeah.
So conclusion, it is hard to remember that smartphones have only been used for us for over a decade, or the internet only really got going in the last 20 years. So we through this we know that the smart technologies and latest technologies are changing the way business are done in this time, and that's all about it. Thank you.
Yeah, Mehtab, I have a question. Adnan, basically, Adnan, you are presenting.
Okay, sir.
How far Business 4.0 is successful in India?
Sir, in India, as the term is coined by TCS, so I think I don't actually know which companies are using these business models, but Business 4.0 is all about using latest technologies in the business model. So many companies are using, but as it's not mine, so I'm not really aware of it.
Thank you, thank you. We can move to the next candidate. Over to the host.
Thank you, sir. So we have completed all the presentations who were present here. So I would like to request Professor Ihtiram Raja Khan for the conclusion of this session. So
Sir?
please, sir. Yes,
Yes,
sir.
sir. Yeah, Gurpreet sir, thank you so much. You've been with me for last 1.5 hours. We have been together.
Thank you,
Well,
sir.
our session started with the keynote address of Gaganji Singh ji, Professor Gaganji Singh. It was a wonderful talk on cloud computing, edge computing, and we were indeed very lucky. Am I audible, sir? I'm audible?
Yes, sir. You are audible, sir.
Okay.
Thank you, sir.
So it was a wonderful session to start with. Then we have had 4 or 5 presentations, and there were good papers, research papers, review papers being presented. My suggestion to the authors is please go through as much literature as you can. Please read as much as you can to come up with quality papers, and then just try and publish review papers first. And once you're through with your review papers, then get along with quality papers, and then just take up any of the data sets according to your field, and then try and develop the system, the simulator, or whatever you are doing, because India is in a phase where our researchers are doing wonderful. We are getting research published at all platforms, whether it is Scopus, it's Elsevier, it's IEEE, we are all getting published. And there are wonderful conferences taking place, mainly because of COVID. Now that we don't have anything to do other than just online classes, so many conferences are coming up and been very successful conferences. And I've been very lucky to join at this Baba Farid College of Engineering for this conference. It was always my dream to be visiting Baba Farid's Dargah sometime in my life. But then when I saw the ad, I requested the Professor Meher Chandji for giving me a chance for this session, and he gave me this session. But really, truly, I'm very happy attending this. The papers were very good, authors were very good, presentation style was very good. So thank you very much. And tomorrow again, I have a session. I would love to see more of the research papers and more of the work. About the college, this is a wonderful college which is having wonderful results and wonderful placements. So in near future also, we'll be seeing the better efforts from them, and even better conferences from them. Thank you so much, Gurpreet sir.
Thank you very much, sir. So thank you this wonderful talk. So on the behalf of Baba Farid College, I would like to thanks to all speakers and participants. And we are looking for your participation in next sessions also. So thank you very much to all of you. Thank you,
Okay,
sir.
thank you. Good evening, sir. Good evening.
Thank you, sir. Good evening, sir. Thank you.
Bye-bye.